Today we'll discuss about mining frequent pattern associations and correlations. Under this chapter, we are discussing about FP growth, a frequent pattern growth approach. So the idea behind this algorithm is it is regressively grow frequent pattern by pattern and database partitions. The method which is going to be implemented over here is the steps are for each frequent item we need to construct its conditional pattern base and then its conditional FP tree. The same process is going to be repeated on each newly created conditional FP tree. The process will be continued until the resulting FP tree is empty or it's contain only one path. Single path will generate all the combinations of its subpath, each of which is frequent pattern. Now we'll take some transaction. It is given over here. TID, it's a transaction ID. It is given 100, 200, 300, 400 and 500. And each and every transaction have some item sets. Like for example, if you take transaction ID 100, here it is having items F, A, C, D, G, I, M, P. And for item ID, for transaction ID 200, we have items like A, B, C, F, L, M, O. Same way for transaction ID 300, B, F, H, J, O, W. Likewise, we have a number of transactions. All the transaction ID have different item sets. Okay. Among this, we will found the maximum possible single items, okay, which is given down. It is nothing but A, B, C, D, F, G, K, L, M, N, O, P. So it is given the bottom. This is a single item, possible single items from this table. Now we will try to find out the support count for each and every item. Right side we have created a table. Okay. So item and support. For A, how many times it is occurred in this table? So based on this, we are calculating the support. Now if you take A is occurring 3 times. See here, transaction ID 100 is having A. Transaction ID 200 is having A. And then transaction ID 500 is having A. So 3 times A is occurred in this table. So the support count of A is 3. And same way, item B. The B is occurred in the table 3 times. See, transaction ID 200 is having item B. And transaction ID 300 it is having B. And transaction ID 400 it is having item B. So 3 times B is occurred. So the support count of B is 3. Likewise, for all the items we need to find out item support, okay, which is created here as a table. Okay. Now here for the first table right side you can see item support. Left side we have items, then we have corresponding support count is given over here. In this you can see the slide down. Minimum support we have taken is 3. Now we know very well either the support count must be 3 or greater than 3 is a rule. Okay. So according to the rule, we will try to check it out in this table. Okay. Those supporting values having less than 3 will be removed from this table. See for example, D is having support count 1. It is less than minimum support. And G, K, L having less than minimum support. And N, O also having it's a 2 support count. It is less than minimum support 3. So by removing this minimum less than minimum support count, okay, we created another tables. item support F, C, A, B, M, P. Okay. So each and every item have a support count. The items which is given F, C, A, B, M, P. This is the pattern. Okay. So next. Okay. So with these items, okay, we'll try to find out ordered frequent items. See, already we have taken F, C, A, B, M, P in the second table pattern. The same pattern it is taken uh, for to find ordered frequent items. See here down, the table down is given F, C, A, B, M, P. It is a pattern which is found from the previous process. Now we will see F where it is occurred. Okay. In 100, if it is occurred, then correspondingly in the ordered item set we can put F. Then C if it is occurred in 100, then you can put C also in the ordered item. Then F, if it is occurred in 100, transaction ID 100, then the ordered items are also having the corresponding items. The same way, if you found each and every item, so whatever given here, that down to the table, okay, all the items will be verified in each and every transaction. If it is available in the particular transaction, then it will be posted in the ordered frequent items. Okay. So the next one, if you take transaction ID 200, there we have F. So F is posted in the ordered frequent items. Then we can check the C where it is there in the 200 transaction ID or not. It is available, so it is also posted in the ordered frequent items. Then A is also available in the transaction ID 200. So correspondingly in our ordered frequent item, it is also posted. Okay. The same way B, M, and P. So we found ordered frequent items. Now we will see for ordered frequent items set, the support count. So another table is created, the same table, okay, which was developed in the previous process. The same table will come over here also. Okay. See, for example, in this ordered frequent item, F is available 1, 2, 3, and 4. It is F is available on transaction ID 100 and 200, 300 as well as 500. So 4 times F is available in ordered frequent items. So the support count for F is 4. And same way the C. So C is available 4 times in the ordered frequent items. So the support count for C is 4. Like that, for all items we have given support count. Next, so with ordered frequent item, we are going to create the tree in the FP tree. Okay. So for our convenient, we are given name like level 0, level 1, level 2, level 3, like that we have. So it is not compulsory to have different levels. For our convenient, for our understanding purpose, we ourselves have given like level 0, level 1, level 2, level 3, like that. Now we will take first table, ordered frequent items. Okay. And the second table, header table. Header table is nothing but which is already we have taken from the previous process. Okay. It is a support count. Okay. Now we can see level 0. The level 0, first we can take a root node. The first node is a root node. Okay. Second node, if you see how many possible the frequent items available. So you put everything is in order. Okay. See, for example, F is available, C is available, A is available, and B is available, M is available, and P is available. Okay. So here we put all. Here we put all. Okay. So everything is available over here. Now, in level 0, all frequent item set will be given as a node. It will be compared with, verified with ordered frequent items. In the table ordered frequent items, the first item set is FCAMP, in which there is no B. So B is removed from the level 0. All other items are given. F is available, C is available, A is available, M is available, and P is available. I will repeat. In ordered frequent items, okay, the first transaction is FCAMP. Okay, so the FCAMP will be converted into node and will be connected with the empty. It is a root node. Okay, in the level 0. So all the nodes are linked and given in some order. Next level 0, level 1, the same thing here we are going to take it. So in ordered frequent items, we will take second transaction. In ordered frequent items, FCABM. Okay, see here from root node F is available and C is also available and A is also available, then M is also available. M is also available. Okay, so next one. So in this level 1, if you consider ordered frequent item table, the second transaction FCABM, F is available in the level 1 tree node and C also available, A also available, but B is not available. So B is taken from, it's linked from A only. So we will take, we can take directly, we will create a link from A to the node B. Okay. So the supporting F4 is a thing, but F is the item and 4 is the corresponding support count. C is an item and 4 is the corresponding support count. Okay. Likewise, for B, it is 3. Support count is 3. You can refer the second table. So it is 3. Okay. Now the level 1 is created. Now we will take M in ordered frequent item table. In the first transaction, M is available. So support count for M is 3, which is already available, already given in the level 0 tree shape. Now again the second transaction also we have M item. So it is followed from, it is linked with B. So from B we are creating on one more node, that is M, but the count to verify or to tally the count, so we have taken the count from the previous M node. So totally if you count this support count for M, it is 3. Now we will go to the next level. Now we will go to the level 3. So here the same ordered frequent items we have taken over here. Next we are going for third transaction in the frequent item set, the ordered frequent item set. For this again we are going to create the tree. So here in third frequent item set we have F and B. Okay. So the F and B we have to create a tree structure. Okay. So already we have F. Okay. So from this F is directly connected with the root node. So from F we will create one more node B to tally the support count. The support count is taken from the previous node. Okay. So it is the level 2. So next we will go for level 3. there the transaction CBP will be considered from ordered frequent items tables. For CBP item set in the ordered frequent items, we are going to create tree structures. Okay. See here, C is a first node, so it should be connected with the root node. So directly we are creating a node C which is linked with the root node. Then followed by B. So one more B node is created. That B node, to tally the support count, it is linked with the previous node and adjusted the support count. So totally we are getting number count is 3. And B and the P, it is followed by B. So it is linked with B. Okay. So to tally this count P, it is also linked with previous node P. So now we created the tree structure. Next level, next transaction, if you go in the ordered frequent items, it is already available. The first transaction and the last transaction both are the same. So we don't need to create any new structure. It is available. This is the FP tree. Here you can see. Okay. So each and every track, each and every one will be frequent item set. For example, FC AMP is a frequent item. FC BM is a frequent item. FP is another frequent item. CBP is another frequent item. FC AMP is another frequent items. Okay. So I am read from ordered frequent item tables. Okay. So from this tree we can find out frequent item set or frequent patterns. So the another one is, so the partition, how we are going to do the partitions and partition the database. Frequent patterns can be partitioned into subsets according to the F list. So the F list is a frequent list. Okay. So frequent item list. Frequent item list is nothing but here FC ABMP. It is we have taken from the previous slides. Then pattern containing P. Suppose if the P is available, then P containing P and consider other nodes. The same way, next containing M but no P and considering other nodes. I think you will understand. Okay. And the next one, okay, containing one by one B and no M P, then will be considered the remaining ones. Like that, one by one will be considered. A new table will be created. See here, the starting at the frequent item header table in the FP tree. Traverse the FP tree by following the link of each frequent item P. Accumulate all transformed prefix path of items P to form a P's conditional pattern base. Now we can take. Be carefully we have to we have to consider this tree. Okay, header table. See here, item C FCABMP. Frequency corresponding support count is given over here. Now, so from this the tree is created already. Now we'll start from the lower level top. So lower level, it is a P2 bottom. It's a P2. From here you can take. Okay. By containing B, we'll consider the first pattern and we'll take over here. We'll write the right side P equal to FC AMB. Okay. See, I'll repeat. Okay. Here you can take the tree last one P2. So if you find this the first tree, first row, first tree by containing B. So P, the remaining all other nodes you can write FCAM. FCAM. The node is nothing but node support count is nothing but P2 count. Why? Because P is containing. For P count, for P support count, we have considered all other nodes. Okay. next flow we can take M, okay, containing M and the no P, okay. The remaining 3 nodes will be considered like F, C, A. See here, F, C, A, okay, F, C, A. And another one is F, C, B, okay. So for F, C, A, what is the count? For F, C, B, what is the count? You can see it over here clearly. Now, by containing B, you can take in the tree, okay. In the remaining nodes will be considered, and they are all FCA, the count will be 1, and F, the count will be 1, and C, the count will be 1. So, wherever you have B, that tree structure, you can take, okay, keeping the B, you can consider other nodes which are all linked with the B, okay. And the support count you can take and the corresponding B. Same way for A and C. Okay. So finally, we found conditional pattern base. Okay. The items are right side we are given C, A, B, M, P. Okay. And the condition pattern base is F equal to 3, F count 3, FC count 3, FCA count 1, F count 1, C count 1, okay, and FCA count 2, FCA B count 1, FCAM count 2, and CB count 1. Now, from conditional pattern base to conditional FP tree, for each pattern base, accumulate the count for each item in the base, in the base, and construct the FP tree for the frequent items of the pattern base. Now, for M conditional pattern base, you consider this tree. For M conditional pattern base, we can start, it is given the red color, you can start from M, okay. You containing M, other than M, what are the nodes are available, you can link it. So FCA, FCA, the node is M node. So we are containing M only. Okay, the support count of M is given here. The right side is given M conditional pattern base. So under which we are given FCA is a 2 and FCB is equal to support count is 1. Right? So FCA equal to 2. How will you get it? By considering the tree. Okay. So from the M you can take, other than M, who are all the nodes connected, you can take, it is FCA. For FCA, the M support is 2. It is given. The same way, on the other side, M. So the nodes which is connected with the M, right side M, is FCAB. Okay. For FCAB, the support count is 1. That is given in the right side M. Okay. So you can take only the red colored nodes. So by which you can understand how it comes. M conditional base pattern, FCA right side, FCA is a 2, FCAB equal to 1 support count. Now you can take, by considering M conditional FP tree, the process will be, you can take the left side for example, the tree left side, from M you can take A3, C3, F4. The F4 is value is 3, which is already counted from the previous slides, we can refer it. Okay. So the same, the tree is again is written over here. So root node F3, C3 and A3. Okay. From these you try to find out the combination with respect to M. Now you can combine these. Okay. F, M. F is for each and everything with M item you try to find out the combinations. So M will be individual. Then F, M combinations. Then F, C, M is a combination. Then A, M is a combination. One combination. The other one F, C, M combination. F, A, M combination. C, A, M combination. The other one is all F, C, A, M combinations. These are all frequent patterns related to M. These are all frequent pattern related to M. Why? Because with respect to M, we find the frequent patterns. Next, the same pattern we can take it over here. Okay. With respect to this first tree, okay, our continuation of the first tree content pattern. If you take AM, okay, the same tree, if you take AM, then you will get the node, the structure, root node F3, C3. You can refer the previous one, okay, the main tree. There you can take AM, A node and M node. Other than A node and M node, what all the nodes are connected in the same tree? If you check it out, you can understand it is coming F3, C3 and root node. Okay. So with respect to AM, it is in a conditional tree. The same way, if you take CM, okay, in the previous tree, in this tree, if you take CM, okay. So other than CM, in the same node, what are the items connected with the root node? F, A and root node. So from this, you can take the straight content. So root node and 3. So already we have taken A. So other than that, you will take the nodes. The next one is CAM. If you take CAM, other than CAM, what are the nodes are available? You can see this tree. Okay. See, we have taken here CAM. Okay. See here CAM. If you consider this CAM in the tree left side, okay, other than CAM, what is the node connected with the root node? In the same root, F only. So here we have given F. The count is already we counted. Support count. This is the regression mining each conditional FP tree. There is a special case. Suppose FP tree has shared a single prefix path. Then how the mining can be done? So mining can be done by decomposing into two parts. One is reduction of a single prefix path into one node. The other one is concatenation of mining results of the two parts. See, for example, here we can take the tree structure is given left side root node, then another node A1 node 1, then A2 node 2, A3 node 3, then from A3 we have branches. Okay. Now we take first part root node, A1 node, A2 node, A3 node. Okay. This first part will define as R1. Then the branches from A3 will take, okay, the another part. If we combine these two parts, right side is given. Okay, combine these two parts, we will be getting, okay, the final tree form. R1 equal to, you can see R1 equal to this one. Plus if you combine these with these branches, R1, okay, so B1, C1, C2, C2, B1, M1, C1, K1, C2, K2, C3, K3. So it is a special case when you have a single prefix, the prefix path, then you can decompose the tree, then you can concatenate the mind results. So next, the benefits of FP tree structures. So by using FP tree, it preserves the complete information for frequent pattern mining. Never break a long pattern if you have in the transactions. And compactness is nothing but it is reduce the relevant informations. Okay. Frequent items are gone. And items in the frequent descending order. Always we will take items in descending order. For example, we will take count if you take F equal to 4, then A equal to 4, then B equal to 3, then C equal to 3. Like that, we will have descending order. The more frequently occurring, the more likely to be shared. Okay. and never be larger than the original database. So why? Because when you take a original database, if it is big, if it is a big database, by doing this FP tree structure process, will be able to reduce the main database. The advantages of pattern growth approach is it's a divide and conquer. Here, what we are doing, decompose both the mining task and database according to the frequent pattern obtaining so far. And next one, lead to focused search of smaller databases. The other factors are there is no candidate generations, no candidate test also. Next one, compressed database. We have here is a compressed database. That's nothing but FP tree structure. There is no repeated scan. Once if you scan it, that's all. Straight away you can go for tree structure. So there is no repeated scan of entire database here. And basic opinion is here, counting local frequent item and building sub FP tree. No pattern search and matchings. The other one is a good open source implemented and refinement of FPGrowth. So you can by referring this one, you will be able to implement the process and you can improve the process. So these are all the advantages of pattern growth approach. So until we have discussed FP growth approach. So this will help you to find out frequent pattern. Thank you.